Hello friends, welcome to the course Exploratory Data Analysis for Data Science with R Software. So you can recall that in the last couple of lectures we had discussed several topics on the measures of central tendency. And we had seen that under different type of situation, these measures can be used, and these measures try to give us the same information in different ways, in different formats. And it depends on us that depending on the objective of the data analysis and the type of information, what we want to retrieve from the data, we can use a suitable tool. Now, we will continue on the same lines in this lecture today. And today we are going to talk about geometric mean and harmonic mean. I'm sure that these are such topics with which you are quite aware, but my job here is to explain you that how we can implement it in the R software and where are we going to use it. So, for geometric mean, I can tell you that, for example, many times you have seen the rates of changes which happen every year, and if you want to make an idea about the average change in the growth rate, then in those cases this geometric mean is preferred. And in case if you want to give some varying weight, means you want to give higher weights to the lower observation or lower valued observations, in those type of situation, the harmonic mean is used. So let us begin this lecture and try to learn how we can compute this harmonic mean and geometric mean in the case of grouped and ungrouped data. So we are going to talk about here first the geometric mean. So geometric mean, just like any other mean, like as arithmetic mean, also gives us the value of the some type of average value of the data. And this geometric mean is more useful in calculating the average value of ratios or say rate of interest, etc. And one important point which you have to keep in mind is that if any of the observation is 0, then this geometric mean is not applicable. The reason being, you will see that here we try to find out the multiplication of all the observations, right? So if any of the observation is 0, then the entire product will become 0. That will not happen with the say arithmetic mean or say median, right, or any other value. So this actually geometric mean captures the compounding nature of the growth, and that is the beauty of this measure. For example, if I want to know the average rate of return over multiple periods, then the geometric mean can be used, and geometric mean accounts for compounding, and which makes it more accurate, particularly in the financial calculations. And in biology also, this geometric mean is widely used to calculate the average growth rate over the time in the population growth studies. The geometric mean is used to analyze the growth rate over the time, for example, in case of several population studies, market trends, and how a user adopts something over a period of time. For example, if I know annual growth of interest rate in the banks over the loan in the 5 years, say something like 25%, 20%, 10%, 20%, and 30% respectively, then this geometric mean providing us a more accurate average growth rate than the arithmetic mean. So in this type of situation where you see that you have to calculate the central tendency of the data for quantities like ratio, percentage, etc., there you can choose the geometric mean to find out the average value. Now let us see how we can find out the geometric mean. So suppose there are n observations, say x1, x2, xn. Now I believe that you understand this terminology very easily, and we assume that all the observations are positive. There is a reason for that. That will be clear to you as soon as I give you here the definition. Then in the case of ungrouped data or the discrete data, this is defined as, say here, the product of x1, x2, xn raised to the power of 1 upon n. And this is denoted as say x bar g, which is the geometric mean. So now if you try to see, we are considering here the product. in case if any of the value of xi is 0, then the entire product will become 0 and that will not really reflect the truth. For example, in case of arithmetic mean, if one observation is 0, then the arithmetic mean is not going to be 0, right? And since we are taking here the product and then the hour operation, that is why we assume that all the observations here are positive. Right. Otherwise, if it comes like something like a negative product and then some power over here like 1/2, then it will be undefined in our case. So these are the condition under which you have to see it, and then you see that is why this percentage ratio etc. they are positive quantities. And similarly, if you have grouped data on or say data on the continuous variable where we have created the frequency distribution as we have done in all other cases like arithmetic mean, median etc. Then the geometric mean is defined here like this: x1 raised to the power of f1 into x2 raised to the power of f2 up to here xn raised to the power of fn, and this entire product has the power here 1/capital N, where capital N is the total frequency. I goes from 1 to small n, and here fi, right? And where we say that these values x1, x2, xn, they occur with the frequencies f1, f2, fn. Now, in case if you want to compute it in the R software, that it is pretty straightforward. Well, there is no built-in function or direct command to compute the geometric mean, right? So if I say this x is my here data vector, then for the ungrouped data in case of, or say in case of discrete data, you can see here if you want to develop yourself how you can develop it. You see this is here the product, right? And then you have here it is 1/here n. So if you try to write down here x1 into x2 into here xn and raise the power of here 1/n, so then you can think that you have learned built-in function PROD, which gives you the product of all the values in the data vector, and then n is the number of observations. So this can be written here as say 1 over say here length of x, right? So that is what I am trying to do it here, and we are finding the geometric mean of the data in such a case by this command PROD of data vector x hat 1/length of x, right? So this length of x is equal to the number of elements in data vector x. So now this is how you can compute it. And similarly is the case that if you try to see in the case of continuous distribution, this is defined here as say 1/here n, say here xi raised to the power of here fi, and then 1/, who can see here, if you have forgotten, you can see here it is here like this, right? And then 1/, here summation this fi, right? So if you want to write down here, then you can write down this part here as say product of say x hat f, and then this is 1/summation fi. So I can write down here hat and 1/ here this sum of here f data vector, and this is what I am writing over here. So you can see here, just by having very elementary knowledge about the built-in functions in the R software, you can compute this geometric mean for this continuous data also, right? So now let us try to take an example to just show you how we are going to compute it. Well, I can clarify here one thing. My idea here is simply to show you that how are you going to write the syntax and commands in the R software to compute this geometric, right? And I want to make this lecture as simple as possible. That is why I am trying to take the same data set which you had used earlier, and my objective is not to use here a very appropriate data set which you can do very easily, right? Yeah, so that is why I am taking here the same data set which I used earlier. It may not really be appropriate to find out here the geometric mean or the harmonic mean, but my objective is to make you understand how are you going to use these commands, right? So this is the same example we have taken, that a customer is visiting a shop every day, and the customer is spending some time in shopping, and that time in minutes is recorded for each of the day. For example, on the day 1, the customer spends say 30 minutes, on day 2 the customer spends 31 minutes, and so on. And this data is now stored here in a data vector minutes, right? So now if you try to consider this data as an ungrouped data or a discrete data, then the geometric mean is computed by this command PROD of minutes and hat 1 upon length of minutes, right. So you can see here this value is coming out to be here like 26.31. It's not difficult at all. And when you try to consider the same data set as the continuous data in the forms of class interval, then we can create here these 5 intervals 15 to 20, 20 to 25, 25 to 30, 30 to 35, 35 to 40, and their midpoints are going to be like 15 plus 20 divided by 2, which is 17.5. And similarly, you can find the midpoints of other interval. And then these are the absolute frequencies, that there are 12 values which are lying in the interval 20 to 25. There are 18 values which are lying in the interval of 25 to 30 and so on. Right. So now we take this data over here. Now you see that if you are trying to deal with this type of data, first you have to create this frequency table, and if you want to use the command table to obtain the absolute frequency, then you need to convert this data in the format of a factor variable on which you can operate the command table, right. So you already have used this couple of times earlier, but I will just repeat it just for your convenience, that we try to divide here the entire interval and we store the breaks point in the data vector here, breaks. And this sequence is created, and this actually intervals are created by the sequence, say from 15 to 30 by 5. So this will create here a sequence like 15, 20, 25, 30, 35, 40, and then we have to create this intervals in which these respective frequencies are belonging to. So we use here the command here cut on this data set minutes using here breaks, which I have obtained here, and then right is equal to false to indicate that the interval is open on the right side. Then this data comes over here. And you can recall that how do we interpret this data. For example, if you try to concentrate on first, second and third this interval, and if you try to look into this here data, say here, let me change the color, say 30, 31, 30. So this is indicating that 30 data is belonging to the interval first, 31 is belonging to interval 2, and similarly here 30 is belonging to interval here 3. This is 30 to 35, right. Similarly, if you try to take here fifth value here 25 to 30 interval, that means the fifth value here is 29. So this 29 will belong to this 25 to 30. So this is how the same data of minutes has been re-expressed in the format of these intervals, and these are here the labels. So now we operate the command table over this minutes.cut data that we have stored here by the name here, you can see minutes.cut, and we get here this type of thing, right. So you can see here that within the interval of 15 to 20 there is no frequency. Between 20 to 25 the customer has spent the times 6 times, 25 to 30 minutes the customer has spent 21 times, and so on, right. Now I need to extract these absolute frequencies so that I can use them in computing the harmonic mean. So we use here the command here as.numeric, and within this I give here the frequency table data. So I use here as.numeric, and within parenthesis table of minutes.cut, and this data is stored here as a f. So you can see here this frequency is 062140, it is coming here. This is the same frequency which is given here 062140, right. Now I have these frequencies. Now I simply need to create here a data vector having the mid values of the class interval. So I compute here this x, and all these mid values of the class intervals are given here, and then f is here. So now I can use here the command here for computing the geometric mean, that is PROD x is the power of f hat 1 upon sum of f, and you can see here this value is coming out to be like this. So one thing what you can see here, this value is coming out to be here 27.02, and when you had considered this data as ungrouped data, this value was 26.31. So you can see here both these values are pretty close to each other and they are not very much different actually, right? And this is here the screenshot. So one thing I would like to explain you here, that now because you have seen that the value of the geometric mean for the same data set, when you try to consider it as here continuous data or say group data, or you try to consider it as ungrouped data, there is not much difference in the value of the geometric mean, right? So in data science also, when we consider the data set, that's usually the size of the data is quite big, and in that case there might not be much difference between the values of the geometric mean which you obtain by considering the data as group data or say ungrouped data, right? So you can use here actually the means any of the command whichever you feel is convenient to you, right? And this is the screenshot. Now let me try to show you these things on the R software also. So first let me copy this data on the R console over here, and you can see here this is here the minutes data, right? And now we operate the command for the geometric mean here, considering this data as ungrouped data. So you can see here this is here the geometric mean of the data, and if you try to consider this minutes data as here continuous data and it is coming from a frequency table in the format of grouped observation, then this is the same data set that is there, but I first need to create here the breaks. So I can use here the breaks is equal to sequence, say here from I can see here what was 15 to 40, right? 15 to 40 and by here 5, right? So this sequence command will give you here the breaks what I have shown you here at 15 to 40 at an interval of 5, 15, 20, 25 and so on. And then I try to create here the minutes data as a factor variable. So I use here the cut command, and you can see here that minutes dot cut is coming out to be here like this, right? And now you have to use here the table command over this. So you can see here once you try to use the table command over minutes dot cut, then it comes out to be here like this, right? And let me try to give it here the same name which I have given here, right? So you can see here this is here the same thing, right? And after this you will have to find out its frequency. So you can see here this is your here table minutes dot cut, and then now I try to extract these absolute frequencies. So I create here a data vector here f, and you can see here this is here the frequency data vector. And now in order to compute the geometric mean, you need here a data vector here x, which is containing the mid values of the class interval. So you can see here this is here x, which is the mid values of the interval, and now you have to simply operate here this command to get this geometric mean. So you can see here it's not very difficult, and you can see here the earlier value when you consider this data as a group, say ungrouped data, then it was 26.31, and when you are considering the same data as group data, then it is 27.02. So there is not much difference from the practical point of view. So particularly when your data set is quite large, then you can use any of the method very easily, right? So now we come to, so now let us come to our next topic, harmonic mean, right? So this harmonic mean is used when there is a necessity to give higher to the smaller values, right? So in case of ungrouped observation or say discrete data, suppose the observation are here x1, x2, xn, then in that case if you try to understand how this harmonic mean is calculated, it is x bar h, which is here something like 1 upon like this one. But if you try to see here, suppose if I say here say zi is equal to 1 upon xi, right? And if you try to define here z bar, so what it will be like 1 upon n summation I goes from 1 to n zi. So now if you try to define the harmonic mean, it will be something like 1 over z bar. So this harmonic mean will become like here if you try to replace here all the values 1 upon n, summation I goes from 1 to n zi, which is equal to here 1 upon n, summation I goes from 1 to n 1 over xi, right. So this is how this harmonic mean of x1, x2, xn is computed. And similarly, if you are having a continuous data which has to be first clubbed in the frequency table as a group data using the class intervals, then in this case the harmonic mean is defined here as like this 1 upon capital N, where capital N is the total frequency, summation I goes from 1 to small n fi, and summation I goes from 1 to n fi upon xi, right. So in our software also there is no direct command to compute the harmonic mean, but we have to write our command in such a way such that I can compute it easily. So if you try to see the way I have shown you here, this expression or this expression, do you think that I can write down here as say 1 upon mean of here z, right? Or do you think that I can write down here it as a 1 over mean of 1 upon x? Yes, exactly. That is the way we are trying to compute the harmonic mean. And if x is my here data vector, then the harmonic mean for this ungrouped data or discrete data, this can be computed by 1 upon or 1 divided by mean of 1 upon x, right. Now next we try to see if we have data which is actually in the format of group observation. So in that case, we will try to create here a frequency table in which the mid values of the class intervals will be obtained and they will be stored in a say data vector say here x, and the absolute frequencies will be obtained which will be stored in a data vector say here f. So this means this the value x1 occurs with frequency f1, x2 occurs with frequency f2, and so on, xn occurs with frequency fn respectively. Now the harmonic mean for such group data or the continuous data can be defined here as like this, sum of here f divided by sum of f of x. If you try to see my formula 1 upon capital N summation I goes from 1 to say here n fi upon xi. So I can write down here as say 1 upon sum of here f, capital N is the sum of all the frequencies, say here I goes from this summation can be written here as say into sum of say f upon x like this. So this is what I am trying to write down here, right. Now let me try to take here the example, and I will take here the same example which I considered earlier. As I told you that it may not really be appropriate to use the harmonic mean here, but I want to make your life simple, and I have taken only couple of examples which are repeated again and again so that you can understand how are you going to implement different types of R tools on the data set. So this is the same data set where customer is regularly visiting a shop, and the time spent by the customer in the shop on different days are recorded. So on the day 1 the customer spent 30 minutes, on day 2 31 minutes, on day 3 the customer spends 30 minutes, and so on. So this data on the minutes here, this is stored in a data vector here minutes, right. And you can see here it is here like this. Now I try to consider this data as a ungrouped data, and I compute my harmonic mean using the command here 1 upon mean of 1 upon minutes. It comes out to be here 26.17. Now if I try to consider here this data as a continuous data, then you know that we need to create the frequency table from where we have to obtain the mid values of the class intervals which are stored here in the data vector here x, like 17.5, 22.5, and so on. And then we need the data vector on the absolute frequencies. So it is stored here as here f with s dot numeric table minutes dot cut, that we already have actually done. If you try to recall that we have done this calculation here, right. So you can see here these are the, this is here your here x, and this is your here f, right. So I am just using it directly here, I am not computing it here again. And then if you try to find out the harmonic mean by writing the command sum of f divided by sum of f upon x, it comes out to be here 26.87. So now I want to have your attention that if you try to see, the harmonic mean here is coming out to be 26.87 when you consider the data as a group data, and when you consider the data as ungrouped data, this came out to be 26.17. So if you try to see, there is not much difference between the two values which you have obtained, right? And this is the screenshot of the same observation, but same calculation, but I would try to, I like to show you it on the our console here. So let me try to have this data on here this. So let us copy the data and paste it here. So this is here the data minutes, and now if I try to find out here this harmonic mean 1 upon mean 1 upon minutes. So you can see here this comes out to be here like this. And now if you try to consider this data as say group data, then the mid value of the class intervals, they are here like as here x, and your frequencies are stored in the data vector here f, so which are here f, you can see here. And so you can now compute this harmonic mean here as sum of f divided by sum of f divided by x. You can write your own command actually, and you can see here that this value is 26.87, and earlier when you consider this data as ungrouped data, then it was 26.17. Now you can see that there is not much difference between the two values. So now if I would like to give you a piece of advice is that you have seen that when we are trying to compute here this geometric mean and harmonic mean for the same set of data, considering them as a grouped or ungrouped data, then there is not much difference between the values of geometric mean and the harmonic means. So when we are considering the situations in data science where usually the data size is very large and data is continuously flowing. So if you try to consider the data as ungrouped data or say group data, and if you try to find out any of such means like as this geometric mean or say harmonic mean, there may not be significant difference between their values. So it will be your decision actually what exactly you want to do and how you want to take a call, right? So now we come to an end to this lecture, and I would also like to conclude here with the topic of measures of central tendency. And you can see here we have considered different types of statistical tool, arithmetic mean, median, mode, different types of quantiles, geometric mean, harmonic mean, etc. But when data comes before you and your objective is to find out the central tendency of the data, or if you want to know where the data is concentrated, then data is not going to tell or raise the hand, please find arithmetic mean or median. It is only you who has to take a call. And in order to take a call, you need to understand that under what type of condition these different statistical measures have been developed. Every measure has some limitations, some advantages, some disadvantages. So you need to keep those things in mind, and then you have to choose an appropriate statistical tool to find out the nature of the or the value of the central tendency measure. Besides these analytical tools, it is also important that you take the help of graphical tools also. For example, we have created the scatter diagram. So you know that when the scatter diagram is created, you can get a fair idea that where is the central value of the data, or around which value the data is going to be concentrated. So my suggestion to you will be that whenever you are trying to deal with some unknown data set for the first time, please try to take the help of graphical tools as well as this analytical tools. And in my opinion, both of them should give you the same information or at least a similar information. If the data has a tendency to concentrate around particular value, then the same value should be visible through the graphical devices, graphical and graphs and plots, and the same value should come out through this analytical tools also. And this will give you a much better confidence to you that what's really happening. But this all will come only by experience. So my suggestion to you is that please try to take different types of data sets and try to decide that which of the tool is most appropriate. And moreover, it is also important that you should know that if someone is using a wrong tool on the right data, then what are the consequences that can come. So it is also important for you that when you are considering the data and trying to implement these different types of tools like as mean, median, mode, etc., assuming that whatsoever is the most appropriate tool, you can decide the value, but try to compare it by applying other tools. Assuming that you are applying some wrong tool over the right data, then what are the values which are coming out? So this will also make you understand that if you use a wrong tool on the correct data, what are the consequences that will come? So this will help you that if some other summarized data is coming before you and you know the nature of data and the properties of data, you should also be able to justify whether these values are correct or not. And based on that, you can take better decisions in data science. So I will conclude here these different topics of measures of central tendency, and in the next lecture, I will come with a new topic on the variation. So you try to practice it, learn about this concept, and I will see you in the next lecture. Till then, goodbye.